Question 10. Do students tend to improve their SAT mathematics score the second time they take the test? A random sample of 4 students who took the test twice earned the following scores. Assume that the change in SAT-M score, second score minus first score, for the population of all students taking the test twice is approximately normally distributed with mean mu. What is a 90% confidence interval for mu? All right. First thing that I want you to recognize is that this is a study that involves paired data. Okay. And what I mean by that is that for each student in the study, there are 2 measurements, right? So each student has a pair of measurements. Okay. So what we're going to do with paired data is we're actually going to look at the differences or the change in the 2 scores and then analyze those differences. All right, so I'm going to write that here, the change, and we're going to do second score minus first score. Okay, so student number 1, 440 minus 450, so their score went down by 10 points. Student 2, score went up by 80 points. Student 3, no change. Student 4, score went up by 30 points. Okay, and so now we're going to essentially ignore these 2 rows of data, right, and just focus on the new row, the bottom row, changes. Okay. All right, to construct this interval, I need to know the sample mean or statistic, the sample standard deviation, and the sample size that I already know is 4. All right, so to find the mean in the SD, I'm going to plug these numbers into Staplet. Hopefully, I have it here already. No, it looks like it got deleted. Okay, so this is the change in SAT math score. All right, the values were -10, 80, 0, 30. Okay, -10, 80, 0, 30. All right. So the mean score is 25 and the standard deviation is 40.4. Okay, so 25, 40.4. All right, so our confidence interval is a point estimate plus or minus margin of error. In this specific case, this is essentially a 1 sample t-interval for mu diff. Could actually write subscript diff on all these. All right, so it'd be x bar diff plus or minus some critical value from the t-distribution times s diff over the square root of n diff. Yeah. Now me personally, if you don't write the subscript diff, it doesn't change the calculations at all. We just write the subscript to remind ourselves that this is an analysis about the differences. All right, so this is going to be 25 plus or minus. Okay, so our critical value is going to be based on degrees of freedom 4 minus 1 or 3. Okay, so 3 degrees of freedom, 90% confidence. All right, let's go ahead and look that up. Table B. All right, so was it 90%? Yeah, 90% and 3 degrees of freedom. 90%, 3 degrees of freedom. So we're looking at 2.353. All right, 2.353 times 40.4 over the square root of 4. Okay. All right. So if we look at all 5 answer choices, we see that they all have the 25 plus or minus, right? So that part is taken care of. All we need to do now is evaluate the margin of error, simplify that. Okay. All right, so I'll just do the calculations off screen. 2.353 times 40.4 divided by square root of 4 gives me 47.5. All right, so we're going to go with choice C.